Okay, this will be the AP Statistics, the Chapter 2 practice test from the book. I kind of want to walk through some of the answers here and discuss some things here. So number one, basically they give you a bunch of information. They give you a percentile here. So it's basically interpreting what a percentile means, and a percentile is always telling you the percent of values that are below your score. Okay, so in this case, the correct answer is E for number one. If he's 73rd percentile, that means that Pete did better than about 73% of test takers. Okay, so E for number one. Number two, they give you a curve. Okay, let me try and sketch this out here a little bit. Something like that. The mean is actually at 2. And they go 4, 6, 8, 10, 12. And they want you to kind of pick out the standard deviation here. In this problem, there wasn't like, I don't think any of the answers were really exact. But I guess the key is recognize if the mean is 2, so that should go to about to the center. And we're having a fire drill, so we will pick this up later. Okay, so this might be a little choppy. We just came back from a fire drill. So we were drawing number 2. Again, we saw the mean was at 2. They want us to figure out what's the standard deviation, or what is it closest to. So if you kind of go through the choices, choice A says 0. It's clearly not 0. One seems a bit small. If you remember, when you get out to like out here, you're about 3 standard deviations. It's probably something like, 1, 2, and just roughly, I don't know exactly where, but 2 seems a little too small. 4 seems about right. I think 5 is too big. If you think 5, if we were at 2 and we went out 5, we would be out to 7, and then the second one would be out to 12, and there'd really be no room to get a third one out there. So just kind of by process of elimination, it's closest to 4 in this case. So D is the correct answer. But again, kind of a goofy question. It's just an approximation deal. Okay. All right, number 3. They give us some information. They give us a mean. This was rainfall, and they give us a standard deviation. Now they want to do some changes to the value. They want to transform the data a little bit, so that because there was an error, so they need to add 0.1 to all values and multiply them all by 1.2, and they want to know what would the new mean and standard deviation be. Okay, so the original mean of 4.6, the original standard deviation was 1.1. Okay, so that's original. Now if we go and transform the data here, when you multiply all the values by something and then you add something to it, that changes things a little bit. So the mean, both of those things are going to affect the mean. So if we add the 0.1 and then multiply by 1.2, that'll give you your new mean. And it should turn out to be 5.64. Okay, so that's the new mean, doing both transformations, adding 0.1 and multiplying. Now the standard deviation, if you add 0.1 to all of the values, that's not going to change the standard deviation. The only way you're going to change the standard deviation is by multiplying or dividing. So that one you're just going to do the multiplication by 1.2, and that'll give you the new standard deviation of 1.32. Okay, so the correct answer for this one should be B. Again, the adding two values does not change the spread, but it would change the mean or the center. Okay, number 4, we have the cumulative frequency diagram or graph, and they want you to figure out what percent consumed between 4 and 8 ounces. So let's just fill in a couple things here. I'm not going to put all the details, but here's 4, and let's say here's 8. I'm going to try and line those up. 4 seemed to be around 20%. Okay, so there was a point there, and by the time you got up to 8, it was up to around 60%. So just trying to line that up, okay? And again, there's some other stuff going on. It was like this, or, and there was a different jump. I know it's not linear throughout, but again, just to kind of get the key points we need. Okay, so what those numbers mean. Okay, so this point right here tells us that 20% of all people consume 4 ounces or less. Okay, that's the cumulative part. Okay, it's including everything below it. And then same thing when you get up to this 8. Okay, about 60%, if we were to line that up, about 60% of people consume 8 or less. Okay, so if we want to figure out or what percent consume between 4 and 8, we would just do a subtraction of those two values. Okay, so 60% minus 20%. So the answer here should be 40%, and that was option B. Okay, a lot of these questions you might see, I think there's one on the quiz, asks for like IQR, the median or something. Let's just do that real quick. If we needed to know the median, for example, let's just say it asked for that. What we would have to do is find out at 50%, we would have to line up to the graph and see, and look down here and say, what's the X value that has 50% of the values below it? That's what the median is. Okay, so you would look up that X value. Or if it was IQR, you would want to look for the 75th percentile, that's Q3. And then look for 25th, that would be Q1. And then again, you would have to do a little subtraction problem of their X values. So I think there was one on the quiz dealing with that as well. Okay, but this one, they just wanted that answer. Number 5, rainfall, Chillyville, normally 55 inches, or snowfall, right? Snowfall. So let's get a little picture going. They're giving me a mean, so I'm gonna throw that right in the center. And then they give us some more information. The snowfall exceeds, okay, so if it's more than 60 inches, 15% of the time. Okay, so up here somewhere at 60 inches, I know the chance of being greater than 60 inches, so this area up here is 15% of the whole curve. So our question is, what is the standard deviation? Okay, so again, there's a couple ways to do this. I'm going to encourage using the calculator. But basically, anytime you see a problem when you know like a mean, a value, and an area kind of thing, and you're putting a whole bunch of variables in and you want to find another one, that's going to go back to finding a z-score basically. So if you remember what z-score is, value minus mean over sigma. Okay, what we need to do is figure out what is the z-score of this value here. Okay, because we know the mean, right? We know mu, we know the value. We're trying to find the sigma in the denominator there, so we need a z-score to complete our equation to be able to solve it. So one way is to look in the table and ask yourself, what z-score has 85% of the values below? Okay, that's how the table is designed. It's always working with how much is below the value. So you would look for a value close to 0.85, work your way backwards. The faster way though, this is an inverse normal case. Okay, and we know the area below is 0.85. And if we want it to be a z-score, you just leave it like that, or if you have the new calculators, it might ask you for the mean and standard deviation. So with z-scores, those are always 0 and 1. Okay, because remember, a standardized score sets the mean to be 0. The old calculators, you don't even have to put the 0 and 1. It's just assumed. Okay, so if you put that in there, it's going to give you the z-score that turns out to be about 1.036. Okay, so that's the z-score of 60. You're just over one standard deviation larger than the mean. You're 1.036 standard deviations larger than the mean. Okay, and what it's going to allow us to do now is throw this into the formula we were talking about over here. And I know the z-score for that value was 1.036. The actual value was 60. The mean was 55. And then we just had the one unknown there. Okay, so just you multiply both sides by sigma, and then you can divide by the 1.036 to get your final answer. It turns out to be 4.82 using a little bit of algebra there. Okay, so that was the answer there. I think it was option choice A. Okay, number 6. Another kind of a goofy question. I didn't like this question all that much, but let's see if we can figure out what they were looking for. We have this big skewed curve. It kind of drops off real fast. And they want to know which of these lines are not part of the 5-number summary. Okay, so like this point was G, so that was like the maximum. The minimum was A. So those are definitely in the 5-number summary, the min and max. And then they had all these lines in the middle, like B, C was out here, D was a little bit farther out, and then E and then finally F up here. Okay, so for me, again, I know 5-number summary is minimum, so I think this is the minimum. Then we need the quartiles, Q1, Q2, which is also the median, and Q3, and then of course the maximums up here. So my thought process was that I don't think that F represents Q3. Okay, to be Q3 would mean that there's only 25% of the values above it, and this to me looks like it's less than that. Um, and also B kind of looked a little small. I didn't think that there was 25% of the values here, so I didn't think B was Q1. So I think B and F were the two that were not in the 5-number summary there. Okay, so the answer for that one was D. Okay, number 7, dealing with heights. So they give you a little different information here. So let's get a sketch here. They're telling us 99.7%. So as soon as you see that, that's reminding me of that empirical rule. It's 68, 99, I'm sorry, 68, 95, then 99.7 rule. So I'm automatically thinking, let's see, 1, 2, here's my mean here. 99.7% of values are within 3 standard deviations of the mean. Okay, so those values are 5 feet and 7 feet. I also went and converted these to inches. Okay, just because when we want to know the standard deviation, inches will probably be easier than converting to decimals. So 5 feet down here I knew was 60 inches. 7 feet, if you times by 12 is 84 inches. Okay, and the mean, of course, would be right in the middle, 72 inches. And now it's a lot easier to figure out. A standard deviation is just that distance to each one of those little intervals there. So you can basically think of it a couple ways. Like from here, if you went out 3 standard deviations, that was a 12-inch stretch. So you have 12 inches divided into 3 equal pieces. So each one of these would need to be 4 inches. Right, that would get you 76, 80, 84. So that would make the curve work out. So that would be your standard deviation, 4 inches for that problem. Okay, number 8. Which of the following is not correct? Okay, so again, just to kind of see what they're doing, they're basically giving you some z-scores, and you need to check if the area that they tell you is correct. So I think you just have to try and plug each one of them in and see which one does not work. So for example, part A says that the probability of z being between 0 and 1.5, and they're saying that it's 0.4332. Okay, so it's saying again a z-score of 0 is right at the mean. There's 1, 2, 3 standard deviations. So between 0 and 1.5, so from 0 to 1.5 standard deviations, they're asking you, is that area 43.32% of the whole thing? And the way to check it out, the fastest way is, if you ever need an area under here, you need a normal CDF, okay, the normal cumulative density function. And just use those z-scores as your boundaries. We started at 0, we went up to 1.5. Okay, and again, the old calculators, you can just leave those two. It will automatically assume you're doing 0 and 1 for the mean and standard deviation. And I think you'll find that one actually does match up. That's correct. Okay, if we wanted to test part B, for example, the proportion of scores that satisfy z being less than -1. Okay, so that would be on this side, and find all the area below that. So that could be done with, again, a normal CDF. Okay, this time our left bound is the super far negative number because we're not stopping anywhere. We'll keep going out up to -1 and then 0, 1. And that one I think actually gives you the 0.1587. So B was correct, C was correct. You just had to go through them all. And the one that was not correct was E. So the correct answer is E. And it was close to the 0.9938, but it just wasn't exactly the same. Okay, number 9, talking about SAT scores. They give you the old mean. So from the 1990s, the mean was 470. Standard deviation was 110. So what would be the standardized z-score for a student who scored 500? So if x is 500, we just kind of need to find a quick z-score here. So z is always that value minus the mean divided by the standard deviation. Okay, and in this case, that turned out to be about 0.27. And it was positive 0.27 because your value was above the mean. So the answer for that one should be E. Okay, now number 10, Jane took the SAT in 1994 and scored 500, so that's kind of the thing we just did. Her sister took it in 2009 and scored a 530, so who did better? Okay, so we know Jane's z-score. We just did that. Her z-score was 0.27. So if we can find out Colleen's z-score, then we can compare the two, even though the means are different. Remember, a z-score gets everything on the same page and kind of standardizes everything. So for Colleen, her z-score, her actual score was 530. The mean was now 515, and the standard deviation was 116. So if we do the calculations on that, I ended up getting a value of about 0.13. Okay, so I think the conclusion would be that who did better and how can you tell? So Jane did better because her standardized score was higher. Okay, so C should be the answer for that one. Okay, number 11, a lot of words in this problem, and sometimes, the problems are really long. You have to read through everything. Part A wants you to compare Jane's and Matt's performance using percentiles, okay, and explain in language simple enough for someone who knows little to understand. So basically, they in the paragraph right above that, they tell you Jane did 40 curl-ups, and she was able to qualify for the presidential award. Okay, and Matt did 40 curl-ups. He was able to qualify for the national award. Okay, so the thing here is in the beginning of the problem, they tell you to be in the presidential award, you need to be in the 85th percentile. Okay, I think it was 85. But to be in the national award, you only have to be in the 50th percentile. Okay, so if Jane was able to get the presidential award, she was in the 85th percentile for her grade, so she did better than 85% of the people. Okay, Matt only did better than 50% of the people. Okay, so if we were comparing the two of them together, Jane's would have been better. And part B was the same kind of thing. If we were able to find a z-score, Jane's would be higher. She's at a higher percentile, so she has more area, below her value, right? So 0.85 might be up here, but 0.50 is just at the mean. So this z-score is going to be higher than this z-score. Okay. All right, and then the number 12, the head circumference of soldiers. Okay, they give us some information here. The mean for all of them is 22.8. Standard deviation was 1.1. Okay, and I believe these are in inches. So again, just to have a little a sketch, okay, we want to find the percentile if someone's head is 23.9 inches. Okay, so my mean, of course, is 22.8. And then this word percentile, it's just a fancy way of saying what percent of values are less than your value. So 23.9 up here somewhere. Our question then is how much area is there below that value? Okay, so there's old school method where you find the z-score and look it up. Okay, or there's the new school method, which I encourage. Okay, again, we're doing a normal CDF. We're trying to find area. So we're doing the cumulative density function. Okay, and we started shading. We're shading all the way out, starting from negative 9999 all the way up to our value. So those are our left and right boundaries of our shaded region. Okay, put the, if we didn't put anything else, it's going to give you the z-score, or it's, actually, never mind, disregard that, I was thinking something else. We got to put in the mean and the standard deviation, and this is going to give us our answer of about 0.84. Okay, so we could say roughly we're in about the 84th percentile. Okay, because 84% of the area is below our value, okay, to the left of our value. Okay, part B, what percent require custom helmets? They say if you're outside of the 20 to 26 range, you need to make a custom helmet. So again, a picture there, means still 22.8. So let's say 20 is down here somewhere, 26 is up here somewhere. our question is what percent will be outside that interval? So we need to find this little piece and this little piece. Okay, and there's a couple ways to do it. You could either do them as two separate problems. Okay, do a normal CDF for the left side, normal CDF for the right side, add them together. Or you might find it a little easier with the calculator. Let's find how much is in there, and then we'll just subtract our answer from 100. Okay, so that's what I was thinking. If we do the norm CDF to find the area in between 20 and 26, okay, and then always mean and standard deviation, that should give you a value, I think it was like 99.3% or something, approximately. So our question was, you know, how much is out here and out here? It's basically everything else. So you subtract from 100 and you get an answer of about 0.7%. Okay, so not many are going to need the custom-made helmets, okay, but a few. Okay, part C, find the IQR. Okay, a little trickier question. Again, think about the picture. Okay, 22.8 is the middle. Okay, to find the IQR, remember that's Q3 minus Q1. Okay, which is the 75th percentile and the 25th percentile. And our IQR is going to be the difference in the value. So here's what I'm thinking. Okay, the 75th percentile is somewhere up here, somewhere where 75% of the values are below that value. So whatever that number is will be Q3. We'll do that in a second. Okay, the 25th percentile is down here somewhere. That's Q1. That's going to have 25% of the values below it. Okay, and IQR will be Q3 minus Q1. Don't give me both numbers. Give me the answer to their subtraction problem. Okay, so how are we going to find Q3? So we're trying to find a value, an X value, so it's an inverse case. Okay, we know we want to have 75% of the area below. Okay, remember that has to be converted to a decimal, 0.75, and then mean and standard deviation. And this will give us Q3. Okay, and that turns out to be about 23.54. Okay, so that's the X value that would fit right there. Q1, finding that, again, it's its own little inverse normal problem. We want 25% of the data below it. Same mean and standard deviation. Okay, and that's going to give me this X value, and that turned out to be, you can verify in your calculators, about 22.06. Okay, so when we go to actually find IQR, okay, remember anytime you see range is like the bigger number minus the smaller number usually. So, so this was Q3, this was Q1. So Q3 minus Q1. Okay, we just do a little subtraction problem. And we should get an answer of 1.48. That'd be the IQR. Okay, and the last problem, can we determine if something is normal when they give us some of the statistics about it? They gave me the mean. Let's write some of this stuff down. They gave me the mean was 48.25. They gave me a median was 37.8, so a little bit of a discrepancy there. They gave me Q1. They gave me the whole 5-number summary basically. So what you can do is look at and say, you know, these, they're not super close, but again, I don't know if that's close enough. It depends kind of on some other things. So you could also look at the difference between the mean and Q3. Okay, remember Q3 and Q1 were given, the quartiles. 21.4 and Q3 was given as 60.75. And you can kind of see that the mean might not be centered. It looks like it's a little bit closer to Q3. And you can also look at the max and min. Max is 204. Okay, while the min is only 2. Okay, so it looks like there's some skewness going on. The mean is quite a bit closer to the minimum than it is to the maximum, so it's not kind of in the center like we would hope it would be if it was normal. So without having the data, we can't make the normal probability plot. So you just kind of have to use some other things. So seeing all of this together would lead me to say it's probably not normal. And make sure you give me a couple reasons. Say, you know, the mean and median are not very close. And then also talk about the difference in here. So the mean is much closer to the minimum than it is to the maximum. It doesn't seem to be centered very well. And that would lead me to believe we don't have a normal distribution of data. Okay, and that is the Chapter 2 practice test in the book.